Okay, now let's proceed to lesson 16. All right, so now we are going to do, let me say, we are going to sketch the graph, the cubic function, and then we're going to answer the following questions. So number one, sketch the following graph, that is f. And then number two, for which values of x is f increasing, decreasing, stationary, concave up, and concave down. So I'm going to actually answer that. So this will actually help you answer any question you will come across in the exam regarding the increasing, the decreasing, and concave up, concave down of a cubic function. Right, so cubic functions and synthetic division, right? So they're going to learn how to factorize a cubic equation. Yeah, and then we'll take it from there. Right, so let me start by showing you what you need in order to factorize a cubic equation, which in this case we're going to use the synthetic division method. But before that, let's learn something here. All right. Let me just say important. Right. So when factorizing a quadratic expression like this, let's say we have ax squared plus bx plus c. When we factorize this, we're going to get two linear vectors. Can you see that? Right? We're going to get two linear vectors. But when you are actually factorizing a cubic expression, we are going to get a linear vector and a quadratic vector. All right, let's say z. Right, and subsequently, you're going to get three linear vectors. Let's say mx plus n. Right. So we know how to factorize a cubic. Sorry, I mean to say we know how to factorize a parabolic expression. So, sorry, a quadratic expression, I mean to say. So, yeah, so that's easy. But now, when factorizing a cubic expression, we need to have a linear vector and a quadratic vector, and subsequently, we will have three linear vectors. Right. So now let's get to it, right? Now let's actually answer number one, right? You have to listen to me, right? On this one. So, solutions. Number one, remember, whenever we are, let me say, sketching graphs, right? First of all, you start by looking for the y-intercept, x-intercept, and other factors as well, right? Or other conditions. So remember now, for a parabolic function, y is equals to ax squared plus bx plus c, we can simply read out the y-intercept, which is actually the c there. All right, y-intercept. Can you see that? So, even for a cubic function, right, the term without variable, which is 12, is actually our y-intercept. Can you see that? So, number one, so for y-intercept, x is 0. So, y is equals to f at 0, which is just 12. Therefore, 0 and 12 are actually the coordinate, or they form the coordinate of the y-intercept. Right, so now let's look at number two. So number two is crucial now. So for x-intercept, we let y to be 0, right? So now, let me tell you something here. Let me write the function actually so that I can explain the synthetic division method. So it's x cubed minus 5x squared minus 8x plus 12. So how to apply the synthetic division method? So we're going to list the factors of 12. Ne? So we always list the factors of the constant term. It's 1 minus 1. It's actually 2 minus 2, 3 minus 3, 4 minus 4, 5 minus, that's, 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 that's bad. 6 minus 6, 12 and minus 12. So these are the factors of 12. So we're going to take not say all of them, but we are going to take these factors one by one and we substitute them into this function. Then if they give us 0, then that means that factor is actually a factor to this function. So let's start with f at -1. So f at -1 is that minus 5 -1 squared minus 8 -1 plus 12. Now let's see what we got. So this is -1 minus 5 plus 8 plus 12. So that's minus 6 plus 20, plus 20, which is 14. Can you see that we are not getting 0? Therefore, that means -1 is not a factor to this function, right? So let's try +1 and see what we get. So 1 cubed minus 5, 1 squared, minus 8 times 1 plus 12. Let's see, that is 1, -5, -8 plus 12. So that's going to be -4 plus 4 and 0. Voila! Brilliant. Now, okay, we get 0. So that means 1 is a factor here. Then you do this. Then you're going to say, therefore, x equals to 1. Then you say therefore x equals to 1 equals to 0. It's a factor to f at x. Then we're going to draw this ladder now. Right? Then here you write this factor which is 1. You write it there. Right? And then here, below this ladder here, we're going to write the coefficients of x cubed, x squared, and x and whatnot, right? So for example, what is the coefficient of x cubed from our function? It's 1. Coefficient of x squared, it's -5. Coefficient of x, it's -12. -8, not 12, -8. And then you've got the constant term there, which is 12. Then what you do, you take this one, you write it here. So this one you see up here is the one from below here. Then I'm going to say 1 times this one, it's 1. Where do you write that answer? You write the answer below the next term. The -5 plus 1, it's -4. You add you add these two terms, then you get -4. Then you say -4 times 1. What you get? It's -4. You write it below the next term. And then -4 plus -8 is -12. And then -12 times this +1 again, it's actually -12. And 12 plus -12, it's 0. Good. Now the last term there, you should get 0. Always. If it's not 0, therefore you're in trouble. It should always be 0. Then see what you do now. Then that means this is actually A, this is B, this is C. So the 1, the -4, and the 12, these are the coefficients of the quadratic factor. Remember, a cubic expression has a quadratic factor and a linear factor. Then you're going to do this. Then you're going to say x cubed minus 5x squared minus 8x plus 12 is 0. And then, what is our linear factor? Our linear factor is x minus 1. That is the linear factor we got up there. Right, then the quadratic factor, what is our a? Our a is 1, therefore is x squared. What is our b? Our b is -4, and -4x, and then minus 12, that is 0. And then now x minus 1, x minus 6, and x plus 2 is 0. Then that means now x is 1, or x is +6, or x is -2. Right, so remember now, the highest degree of a cubic function, it's 3. So that is why we have 3 linear factors. That is why we've got 3 linear, yes, I'm right. That's why we have got 3 linear factors, and subsequently we have 3 x-intercepts. So the highest degree of a function determines the number of linear factors we're going to have and the number of x-intercepts we are going to have. So we are done now. We just found our y-intercept, our x-intercepts. Now let's look for the turning points. That's condition number 3. So you're going to say for, condition number 3. Then we're going to say for turning or stationary points, the first derivative is 0. I've shown you that, or I've demonstrated that on the previous lesson, that the derivative at the at the turning point is 0. So now let's have our equation, our function there. So I've got this, we have got that, we have got that, we have got that. Now let's differentiate. So when you differentiate this guy, you have 3x squared minus 10x minus 8. Right. So minus 8, yes. Now remember, at the turning points, the first derivative is 0. Then now, f at x is actually 0. So that means 3x squared minus 10x minus 8 is 0. Now let's factorize that. If you don't want to factorize, you can actually use a quadratic formula. So that is 3x plus 2, and then x minus 4 equals to 0, and then x is minus 2 over 3, or x is equals to 4. So we use the first derivative to get the x coordinates of the turning points. We only use the first derivative to get the x coordinates of the turning points. Now, how do we then get their partners, right, which are actually the y values? Then we're going to take these x values and substitute into the original function, right? So that means now f at negative 2 over 3 is actually negative 2 over 3 cubed minus 5 negative 2 over 3 squared minus 8 negative 2 over 3 plus 12, and then you get something like 400 over 27. Right. Now for the 4 one, f at 4 is 4 cubed minus 5 times 4 squared minus 8 times 4 plus 12, which is actually negative 36. Therefore, negative 2 over 3, 400 over 27, and 4 and negative 36 are actually the turning points, the coordinates of the turning point. Coordinates of the turning points. Turning points, right? So I said to you now, the number of turning points is actually the highest degree minus 1. So the highest degree for a parabolic function is 2. 2 minus 1 is 1. That is why for a parabolic function we've got 1 turning point. But now the highest degree of a cubic function is 3. So 3 minus 1 is 2. That is why we've got 2 turning points for a cubic function. Right. So another thing that you must get now, the fourth condition, is the point of inflection. Point of inflection. All right. So for the point of inflection, the second derivative is equals to 0. Right. So now I will actually explain the point of inflection when we are doing when answering number 5 and 6, right? So basically what the point of inflection tells us, the point of inflection is telling us about the concavity of the graph, right? Whether the graph is concave up or is concave down, right? So that means now we have to differentiate the derivative of the derivative. So remember, our first derivative is actually 3x squared minus 10x minus 8. So now the second derivative, simply means the derivative of the first derivative. So it's going to be 6x minus 10. But now remember, for point of inflection, the second derivative is 0. Therefore, second derivative is 0. 6x minus 10 is 0. And then x is 10 over 6. And then x is 5 over 3. So now, how do you get now the y value of the point of inflection? You substitute into the original function. So f at 5 over 3 is actually 5 over 3 cubed minus 5 times 5 over 3 squared minus 8 over 5 over 3 plus 12, which is actually negative 286 over 27. Right, exactly. So now, in that case, what do we do? Then we're going to say, therefore, 5 over 3 and minus 27, minus 286 over 27 is actually is the point of inflection. So this is actually the point of inflection. This is the point where the graph changes its concavity. So now, let's do this. Let's actually sketch our graph. So let's sketch our graph. So sketching our graph, we do this. Right. We do this. Number one, let's check our graph. What is A? A is actually positive. All right. So A is positive. That means our graph will take. Remember, when A is positive, that means our graph will take this shape. And then when A is negative, our graph will take that shape. So right. So that means our graph will actually take this shape. Let's right. So all right. So remember the the turning point is -2 in front of them. Okay, and that. So that means now our function will be like this. Our function will be like this. Oh, I tried my best there. Please give me a round of applause. I really tried. Right. So here we've got 1. Here we've got 6. And then here we've got that negative. Is it -3 or -2? Oh, sorry, it's -2. It's not negative. Oh, look at what I did. Okay, I can still get it back. Yeah. So it's -2, right? So remember here, you're going to have -2 over 3 and 400 over 27. And then here we're going to have positive 12. And then here we're going to have 12, 4, and -36. Can you see that? So that means this is going to be our -2 over 3. And that is our 4 there. So this is our beautiful graph. However, now we have to have our point of inflection somewhere here. So, okay, let me just remove this one here and try to squeeze it here. Now here we are going to have a point of inflection, which is 5 over 3 is to -286 over 27. But I know, my learners, okay, you can draw better. Actually, space here is a problem, but I know you can draw better. Right, you can drop it. Now let's say, okay, so the point of inflection is 5 over 3 minus 286 over 27, right? And then here we've got positive 1 as the x-intercept. I know my handwriting there is bad, but you can draw better, right? So you can draw better, But now before I conclude lesson 16, before moving to lesson 17, let me actually show you something here, right? But in fact, let me show you that on the next lesson. All right. Let me show you on lesson 17.